Next, we're going to talk about other types of programming and how they don't really fit inside of microcontrollers. Like, they get more English-based and more complex and more out there, and the memory is just so much that the microcontrollers can't handle it.
Exactly. It's like as if you really can't put Java or C++ really inside of a microcontroller, but you can fit them on a bigger machine, on bigger machinery, like computers and televisions and such like that.
Yeah. Well, now, you see, it interrupted.
Hey, Alex!
Oh, hey, Thomas, how's it going?
It's going pretty good.
Now, you see, that right there was an interrupt, and that applies to us in our code in the sense that we start off with the main, and we're going through, and all of a sudden, boom, interrupt happens! When an interrupt happens, it goes through the interrupt, and when it goes to the interrupt, it then starts back where it left off, like a loop. Exactly. Yeah.
In our code, we actually use a binary sequence to count LEDs up. And binary is a base kind of language for the computer. What a binary, it's a very long string of characters that actually spells out letters that we actually use in programming. We also use decimal, which is what we actually use today. It's going 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then along with that, we use hexadecimal, which hexadecimal does 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it starts A, B, C, D, E, and F. And so that's how that sequence goes. And some examples that go along with that are timers. Timers are a very crucial thing for us in everyday lives, like windshield wipers. You may take them for granted, but seriously, windshield wipers, without that, it would be really hard for us to do that. Double clicks on a mouse. That's also really important for editing and trying to get to places quicker and faster. And also lights that actually go on outside of your house, they can also have a timer as well. And also the lights, they're set on a timer and they count up, and once they reach a certain point, they'll turn off or they'll turn on when something moves or at a certain time of day. Okay, so this right here is our real code, and right here, this is our main. Our main includes a portion that's the sysinit, and then it'll create a pause, which is 500 milliseconds or half a second, and then it'll trigger the global interrupt, which is the GIE, and it'll go through a while loop, and then from there it'll pause 100 times, which just are 100 milliseconds. And then it will return and exit.
So, with the interrupt, when a sysinit happens, it goes through and sets all these bits, and then it will activate this GIE. This GIE is activating the interrupts. And so we come to our interrupt code, and we have a GIE equals 0, and this will deactivate or de-enable. It will disable and stop further interrupts from happening while it's going through this one interrupt, so it doesn't interrupt itself.
Right.
So this next instruction is an LCD go to, which is basically telling the microcontroller to go to a certain spot on the LCD, which will be the top left-hand corner. Then it will put in that slot, video made by. And, of course, never forget semicolons, always important. Then it will pause for 1500 milliseconds to give it time to have that up there so you can actually read it and it doesn't blink past your eyes. And then it'll do LCD clear. And then it will then go to the next portion where it then basically repeats. Now, as you'll see in this next section, it has LCD go to 0x40. That is hex in what we talked about earlier, or later, whichever part we put it in. And 0x40 means go to the second line on the left-hand side. So it's basically just placing where we want the words or words to go or the numbers to go. And so that's repeated throughout here so we can have each of them throughout.
Okay, so the sysinit, this is declarations that will be, or instructions that will be enabled. So we'll have
all these different
just
ones.
all these different types of instructions that will be enabled throughout the sysinit that will...
Like this activates the LCD, and the TRISB will activate to let you know that the button is an interrupt itself. making the button an input is basically what it's setting it to. And then we have the option reg and setting it, so we have this option reg is the timer, isn't it?
Yes.
Yeah, and then we have setting global interrupt here to make sure it's actually is set up and everything. And so that's the code.
Bye! So, today we're going to talk about this and that and this and that. And then when we finish that, we're going to talk about this.
And then after that we're going to talk about whatever's behind us, and then after that we're going to look at these lights.
Yeah.
Yes.